Welcome! Today we're diving into WebSockets and their power in real-time data streaming. We'll connect to a live feed, track updates, and test response speed. Let's get started.
To see WebSocket in action, we'll connect to a real-time data stream using Binance's public WebSocket API. It delivers live market price updates, allowing you to track changes instantly. Our goal: connect, receive price updates, and measure latency. Let's set it up. First, let's import the necessary libraries. Import async.io, import WebSockets, and JSON and time. Now let's set up our WebSocket URL and define a latency threshold. We will copy that and define Binance URL. And we are interested in trade, and let's make it Bitcoin USDT and define max latency 1 second. This is Binance's public WebSocket URL for Bitcoin USDT trade updates. And now let's define a function to connect to a Binance and receive live data. Test Binance WebSocket. And next, let's establish the connection to Binance's WebSocket. Try async with WebSockets connect Binance's as WebSocket. And let's print the connection state. Connected to Binance WebSocket. If it fails, the program will handle the error. Now we'll listen for messages and calculate how long they take to arrive. Let's define received price, empty table, and latencies. Also for in range, let's say 10. Start time equals time message await WebSocket receive, and time equals time latency equals end time minus start time, and latencies append latency. And we collect 10 messages, measure latency, and store the response times in latencies. Next, we'll parse and validate the data to ensure it contains the required fields. Let's define data equals JSON loads message. And then we check for the symbols assert. Let me check the documentation. And let's go for P, price, symbol S, and quantity. So it will be S. Error, missing field S. Symbol. Price. And quantity. Symbol equals data S, price equals float data P, and quantity stands for Q. Now let's log the received market transactions. Print f string trade received symbol price USDT quantity and latency. Now let's use previously defined table received price and append price. Now we can try to run the code to see if it works. Except it's missing here. We can make it pass just for a test. And let's run pytest as for logs async IO mode auto. Nothing happens, but we can see connected to Binance WebSocket. Something is wrong here. Await WebSocket receive messages. I think it should be receive, just receive. Okay, works. We can see the price, quantity and latency. Now let's add assertions to check data correctness. Assert price is greater than 0, other way, error, invalid price received, and assert latency is smaller than max latency, other way, warning, latency exits max latency. Let's reduce the number of decimal places. And let's run the test once again. Now looks much better. Now we'll summarize the results of the test. Assert received price is not empty table, other way, error, no Bitcoin USDT prices received. And let's define average latency equals sum of latencies divided by length of latencies. And now we can print average latency WebSocket latency, average latency seconds. And we can also print the information about test state. WebSocket test completed successfully. So we calculate the average latency and confirm that we received valid data. Now let's add error handling to manage connection failures. So let's write except exception as E, and it will be the default one. Print unexpected error while testing WebSocket. And the second one, exception WebSockets exception connection closed. Print error WebSocket connection was closed. If the connection closes unexpectedly or any other error occurs, the test will display an error message. Now let's run our test and see it in action. That's it, we successfully connected to Binance's WebSocket, received real-time price updates, and measured response latency. WebSockets are a powerful tool for handling live data, and this test ensures our connection is stable and reliable.